Righto, doing a bit of field strength testing today on, I'm going to do 3 antennas today. The full-size Springer, triple top load and the AM Pro. And just to sort of plot the directional behaviour of these antennas at a low radiation angle on the Polo. Just for a bit of a laugh really. Anyway, I'm going to do various tests around the vehicle, and I'll be using my little Macom AH27. I'm going to be doing this on the top end of the EU block. SWR will be absolutely fine there. Reason is the 2781 UK FM band has got quite a lot of users around here, and a lot of them are farmers and things. I wouldn't want to disrupt their comms. I will be doing the test on low power on this little handy, and that probably equates to half a watt. So even though I'll be keying up constantly, I shouldn't be causing any interference. And indeed, there's no skip running at the moment. So channel 40 on the EU or thereabouts will be pretty much as clear as a bell. So I'm going to show you the sort of setup. It's very rudimentary and no doubt technically flawed, but there we go. That's what I will be using, and afterwards I'll plot the results on a drawing, and we'll see what we've got. Okay, the antenna on the vehicle on a fixed mount, as we've seen before, and I've got a great big long piece of string that will be going to a field strength meter mounted on a tripod to keep a sort of constant, a sort of repeatability going as I move around the vehicle. So yes, that's what I'll be doing, and yeah, I'll show you the other end and we'll take it from there. Right, there's the meter on top of the tripod on the taut piece of string, and what I've done just to bring the signal up a little bit for the field strength purposes is just put a patch lead in the back there for a bit of a counterpoise. Normally your body would be the other half of the antenna, so to speak, with these field strength meters, as they're designed to be sort of handheld as you take the readings. But I want to keep away from it so my body doesn't interfere with it, and also with the string, etc., to keep a bit of a constant going, to give the antennas a fair chance, and to give me some reading repeatability, if you get my drift. Anyway, it's just an old CB type field strength meter. It's only a comparative scale from 1 to 10, so you endeavour to get a bit of a reading on there, and then just walk around and take the results as you go. So I'm going to go and key up and see where we are with it. There's no specific sort of field strength setting, at least on this one. All you do is, done as I've done there, put it in SWR mode and move that rotating dial to get a reading, and as you go round you see how high or how low one position compares with another. Right, let's crack on with that. Okay, I've worked out a series of data points as we go round. So it'll be front centre of the vehicle, and then various sort of lines that I can strike off of to make sure that one antenna gets compared in the same location as the previous one. So I've got 3, 6, 7, 8 data points, so to speak, as we go around the vehicle. I'll only do around one side because the antenna is in the middle at the rear, so one side should be a mirror image of the other, and it's not long before it's tea time, so I'm going to crack on with that, and yeah, we'll see how we get on. Okay, I've got a line now struck from the front door shut, and we're now showing again about 3.8, 3.9 from that one. Right, keeping the string taut and the meter in the same orientation versus the vehicle body as I go round, because the meter itself would be a little bit directional, as you can see. So now of that strip there that separates the back window from that little rear quarter light type thing, we're now showing just over 3. I give that about 3.2. Okay, straight off the rear door shut line, we are now showing down to about 2.8, maybe 2.9. Right, now on the rear tailgate shut line, we are showing I'll give it 2.1. Okay, now we're halfway around the back, halfway along the rear window, and we are showing at 1.8. Right, straight off the back door, directly behind the antenna now, we are showing I'd give that 2 dead. Right, triple top load is on there now, so exactly the same setup. So I'll just show you that first reading straight off the back door, and then I'll cut the video and just take the plots. So I try not to show my number plate because people only copy the plate and I'll end up getting the fines come through or some sort of cloning thing. So yeah, we are showing, interestingly, about 2.25 there, 2.25 straight off the back door. Right, let's plot the rest of these twigs and I'll get back to you from maybe the whiteboard. Righto, I've plotted an omnidirectional circle on this rather poor whiteboard with rather poor marker pens, so you never know, perhaps somebody will be kind enough to buy me a new whiteboard and some markers for Christmas, but in the meantime we can only work with what we have. Anyway, it's an equidistant circle. It's not a representation of the actual gain around the vehicle, because basically that's a representation there of the 5-meter piece of string and the test points as I went round. Now I only tested, because the antenna is centrally mounted this way, I didn't test that side because these are going to be the same. Had it been the RAV4, the antenna is on this side, so we would see more gain, so these figures would be higher on the RAV4, they should be, than they would be on this side. But seeing this is centrally mounted, it will be a mirror image each side. No other clutter on the roof of the Polo, as you've seen. Ideal situation, apart from the only thing that would be better if it was centrally mounted in the roof, but we do have a proper roof mount drilled and fixed and well grounded. So let's have a look at the results. So I ended up doing 4 antennas. I keep calling it a fire stick, but so does everyone. It's a Thunderstick 7-foot, the Springer, the triple top load, and the AMP Pro antenna. And the results have come through, and it pretty much confirms what myself and other people have been saying. The bigger twigs, they are hilltoppers twigs. They need a good takeoff towards the horizon, unimpeded takeoff to the horizon, because they are low or lower radiation angle antennas. Whereas the shorter antennas, worst being the base loaded ones, they are more high angle. Therefore that's why they've done quite well on the test so far, because the test so far, it's all been no line of sight and down in amongst hills and trees and things. So in an open location, I think now I can predict what's going to happen on Shootout 5. Shootout 5 is going to be the top of a hill with a really good launch towards the horizon. So let's start from the front. Thunderstick 7-foot, 4.5 on the meter. AMP Pro, 4.5 on the meter. So I'm expecting these 2 big twigs to be pretty much the same on the signal strength meter when I do that next test, followed by triple top load. Was giving us a 4 on the field strength meter. Base loaded Springer 3.5. So it does illustrate that the bigger twigs are punching more at low radiation angles, followed by, as you would expect, the top load. Last place, the base load. If we'd have had a center load antenna, you would expect that to come in between those two. The most efficient as far as low radiation angle is concerned with loaded antennas is top load, the least efficient is base load, and the one in the middle is center load. So yes, there we are. So Looks like they could be a fair whack up on the base loaded Springer when we get to this next test. I'd have to really get into the mathematics and number crunch to try and predict that, but we should see some clear blue water between the big twigs and the smaller ones once we get out there. And that is the trend all the way around. 7 foot, 4.8. AM Pro maybe slightly up. Now that would be in the direction of pretty much maximum gain this way, because that's the most metal there, look. Slightly less metal that way, so that's why centre front is slightly down on this one and this one, because following the metal, you have more gain slightly in this direction, more gain slightly in this direction, and a slight flat spot, slightly lower gain straight at the front of the vehicle. As we go round again, 4.85, 4.85. Looks like the AM Pro may be slightly, probably not noticeable when we actually get to look at the meter, the received meter. But that's within tolerance. They're pretty much the same, but it's definitely a consistent trend. The big twigs are up on the next one down, which is the top load. Next one down then is the base load. Again, 4.25. I think 4 there was at 4.8. I may have rubbed that out. Test result number 4. Yeah, slightly up actually on that direction for the fire stick or the thunder stick. Some sort of beetle thing flying around. There's all sorts living in this shed. Big spiders, small spiders, you name it, it all lives in here. It is a proper genuine shed. As we go round again, 3.8, 3.8, 2.8, 3.25. The trend is there all the way around. The only one maybe the AM Pro is slightly up in the worst case minimum gain direction, which is straight off the back of the vehicle. 3, 2.5. So it's too close to call, but certainly when we get up to this hilltop, I'm fully expecting these big twigs will show clear blue water between them and say the 4-foot TTL, and certainly the base loaded Springer. Okay folks, right, so yes, I quite enjoyed doing that bit of field strength stuff. That's something relatively new to me actually. I did muck about with that type of thing when I was about 14, but there we go. It did occur to me that something sort of that was fairly prevalent back in the 1980s as far as SWR meters having a field strength antenna connection. It's not something you see very often these days, so I was glad that I remembered I had this little Mr. CB meter here. I did have to fashion an antenna for it because the antennas on these field strength meters seem to go the same way as mounting brackets, and you know, the little battery covers on the bottom of bass microphones, they always seem to disappear somewhere into the ether. But that happened with this thing, so I just have to I'd have to bend up a little antenna there out of wire, but it all worked really well, so I'm very pleased with that. And I was pleased that the results seemed to have some consistency, and they did match what you would expect from the antennas, as in the really big long antennas were very strong at low angle radiation, and the top loaded antennas were better than the base loads. So yeah, that pretty much gives me the confidence to predict that on the next shootout, and there's going to be another shootout number 5, I will be going to a hilltop location with a really good signal launch, and that should suit these big antennas, and we should finally see some clear blue water on that receiving signal strength meter between these big twigs and say the medium-sized twigs like the triple top load, modulator, Springer, etc. So that's what will be coming up, and I'll do a conclusion either as part of that video or I don't know, lick my wounds type thing if they're still crap after that one. So we'll see, and I'll let you know what I've ultimately decided to do with these antennas. But certainly we have it's not just been one factor with these big twigs while they've sort of underperformed. Initially on the RAV4, it's shown us that these big antennas need an absolutely ideal install on the vehicle. as in with the Polo, it's now on a fixed mount, and you've seen them rise up and just about surpass the performance of the medium-sized antennas, whereas on the RAV4, I think the big quarter wave was actually down on, say, a 5-foot fire stick and a 4-foot triple top load. So it goes to show they need a really good install, no clutter in the way as far as racks and bars and things, uncluttered roof like we have in the Polo, nothing to, because they're radiating lower down, anything that's going to get in the way. They need to be up on the top of the vehicle, ideally in the middle of the roof, on a fixed mount. Probably, I've not used one, but probably one of those triple mag mount things. It's like 3 magnets in a triangle with the mount in the middle. Something like that probably would give you a good enough capacitive connection between the mount and the vehicle body to give the antenna a chance to shine. I don't know, I've never tried one, but certainly we've seen the performance come up on a Polo versus the performance of those antennas on top of that roof basket. Now, we're not talking SWR. SWR on that roof basket, superb. So it doesn't correlate that SWR equals performance and efficiency. It doesn't. It just shows that you're not reflecting too much power back to your radio, and then in extreme circumstances you could blow your radio with so much reflected power. It's good to a certain extent, SWR as a test, but as we've seen, it's not everything. So yes, so as far as the RAV4 is concerned, I don't think I'll bother with the big antennas. I think I'll just do what I said in the last debrief. Little Dynamatch on there for local work, car-to-car comms, touring antenna, probably the Springer, or I do have a antenna that's literally just arrived that I'm going to be having a look at and reviewing soon, and that is the Dynamatch, the half-breed copy, little 1.5 metre antenna. I'm not expecting it to perform any better than the Springer, but it'll look a little bit neater on that RAV4, because that's still quite a tidy looking motor, that RAV4, and if I'm sort of touring around with misses or whatever, the Springer may look a little bit, should we say, agricultural. But don't get me wrong, I really do like the Springers, but maybe I may go with that one as the sort of touring antenna on the RAV4. Anyway, so yes, indeed. So what we've learned so far is that we've managed to bring the performance up of the big antennas, so they're slightly better than the medium-sized ones, say the 5-foot Fire Stick 2 and the triple top load, but not as much as you'd expect. But at the end of the day, what we're dealing with is on all of the previous shootouts, and I keep pointing that way because it is that way where I do my my transmitting station. They are in undulating terrain with no direct line of sight, and I deliberately choose a sort of dip or something. So I wanted to prove that in a real-world situation, what antenna would you choose? And I think for real-world situations driving around, I've done that. But it's been to the detriment of the performance of the big antennas, because as we've seen from the field strength, they're radiating more efficiently, lower down. But in undulating terrain, that's not always the best thing. As we've seen with the short antennas, they are down, such as the Mini Springer, about an S point down, which is quite a lot. Small increments on an S meter do actually equate to sizable differences in gain. So I think an S point is 6 dB, half an S point is 3 dB, 3 dB is double. So if you had one antenna and another one that's half an S point up, you'd have to double the power. You'd have to go from 4 to 8 watts to bring that signal on that first antenna up to the level of the second one. So that's what you're dealing with, just half an S point. In gain terms, it's quite a lot. So yeah, anyway, we've brought those big twigs, so they're just surpassing, but not by as much as you would have thought. But that's because they are quite efficient, and we're in some pretty undulating terrain, and it goes to show that in that sort of situation, a real world situation, you may as well go with say the Springer, base load Springer, modulator, something like that, because they are radiating not at, like I say, a really high level like the small twigs, quite dysfunctional radiation pattern, but they're somewhere in between, compromise, and they're firing their signal out. It's riding the hills, it's hitting the hill higher up than, say, the efficient longer antenna, and it's got less to do to ride those hills, that signal, back to the receiving station. So that's allowing these medium-sized antennas, I think, to punch above their weight. Someone did mention perhaps you've got a bit of NIVIS involved there. I did look at NIVIS a few years back because I had a very odd contact. It was too close for sporadic E, but there was no way it could have been a ground wave contact, if you know what I mean. So I thought, what I was looking, perhaps it's NIVIS and the rest of it, but it turned out, as far as I could work out, it was backscatter, because the sporadic E at the time was so strong. We were getting a phenomenon called backscatter, where the signal hits the atmosphere and it sprays back, so to speak. So you get some sort of odd things happen where you're hearing things. You think, well, that's only 50 miles away. Sporadic E is sort of 250 to 2000. It's too close for sporadic E, but too far for ground wave. But it's probably backscatter. So I put it down to that, because I did look into this at the time, and as far as I could tell, no one or no one has documented, and a lot of people said this positively never happens above 14 megahertz, and we're up to almost 28 megahertz on the UK FM. So I don't think it's anything to do with this. I think with the AM Pro, I think it had a bit of assistance from an aircraft, I would imagine, because we're right in the flight path of Bristol Airport, and I think probably as that signal was making its way back to the base station here, it got a bit of a reflection off of an aircraft probably, and that just made that signal just come up as that aircraft passed over, and then just leveled back down to not far off what the other big antennas were. And in the end, it was pretty much nothing to choose from between 7-foot fire stick, IMAX 2000 top load, and the quarter wave tank whip. So anyway, I think this time we will see clear blue water on Shootout 5, but indeed. So yes, going back to this line of sight thing, I think the efficient antennas are putting the signal at a much lower angle. They're hitting those hills much lower down with the signal, and they've got then more to do to sort of ride those hills back to the receiving station. So we've seen that that now sort of leveled out a bit, but going by those field strength results, I think once I get out to location for Shootout number 5, that's really going to whack that signal out, and we shall see. So I'll stick my neck out and make that prediction, and what I'll end up with, I think, is on the Polo, I don't think I'll bother with a tiny little short antenna. I think because the vehicle is low, I think I'll either stick with the Springer or the modulator on that one, and in each of these vehicles, like I say, I'll probably just pop the 4-foot triple top load in there as well. And Shootout number 5 will illustrate whether, if I go out with the Polo up the hills and mountains and a bit static mobile DX, Shootout number 5 should prove one way or the other whether it's really worth taking these big twigs with you or just not bother. And if there is clear blue water, we'll see what happens. But I think I will, because they're two-piece, I will either stick the AM Pro in there or the quarter wave tank whip, unless of course that fire stick 7-foot, the thunder stick 7-foot, really starts to perform, and might be worth that extra effort to take that longer twig. But we will see. So I will catch you on the next video. So I've got this one coming up, do a test on that one. Might even do a back-to-back test out in the field as a little mini shootout. But catch you on the next one, and keep an eye out for Shootout number 5. Might be a while, because it's going to be a fair bit of distance to go and a fair bit of setting up to go, because the last thing I want to do is drive up probably a, I don't know, 100 mile, 150 mile round trip just to get back to the base station and find out the camera's gone off because of low battery or some such crap like that. It's happened with these shootouts, but at least it's not that far to go to have another go. The last thing I want to do is do a bloody great big shootout, so I have to make sure somebody's back at the receiving station to make sure it's all working and to make sure it stays working. So cheers and beers everyone, and we'll see you soon.